Yeah, so good morning, everybody. I'm Lisa, and I work in STMicroelectronics in the MEMS and sensor subgroup. So my colleagues just conclude a speech about connectivity. Now it's time for sensors. And in particular, today, we talk about sensors for wearables. And we want to touch two important topics. The first one is about sports, and the other one is about healthcare. And every evening when I go to sleep, usually I'm saying, okay, tomorrow morning I will get up 30 minutes before, and then I will train myself with some sports, because then I'm feeling better. So for sure, I'm feeling, yes, healthy. But at the end, it never happened. But this is my personal experience. Maybe you are better than me. So let's start to look about, it's not going on. I think, okay. Okay, so let's start from an analysis of what is happening in the market. So I want to go through some mega trends about sports and healthcare. So what is happening in sports? What we see is that all of us, whatever you are, a professional athletic, or let's say a standard one, like us, we want to have more and more analytics on what we are doing. And this is really an increasing trend in the market. The other one is when we are having sports and some injury happened to us, we want to know how we can prevent the injury and how long time is needed to recover from this injury. And the final one aspect that we want really to know more is about concussion. When we have a concussion, we want to know how to manage it and by when I can be back to my daily. And this is what is happening in the sports area. Then there is another important area that for all of us, so we are humans, it's about our, let's say, age. What we know is that the aging population is increasing. So we want to have a longer life, but it's not enough just a longer life. We want to have a longer and better life. And the other mega trend is that the young population is decreasing. So we have to take care more of the situation of all the humans. So what we can see is that at the end, sports and healthcare are not anymore separated. There is a convergence between these two different areas, and the result of this convergence is, for us, or at least where we see how sensors could make a difference, is in the motto, train like a pro. What does it mean? It means that having the convergence of the two different fields, there are new opportunities. New opportunities that for sure give an answer to our needs as humans, but also give an answer from the technology standpoint. So what we see as emerging is a market for wearable technology that anyhow has already started, but not only on the wearable. There is also a need on the sport medicine, because we want to know, again, how fast I can recover, am I ready to come back to my sport? So I want to know more about that. And finally, there is another important emerging market that is about our mental health. Again, we want to live more, we want to have a better life. Our mental health is one of the key points. So in front of those new opportunities, as ST, and in particular now about MEMS sensor, how can we help? How the technology that we offer to the market can help for those new opportunities. So we analyze the challenges to help all the humans to have a better and live a better life. And what we understood is that for both field, sports and healthcare, the technology that we offer must first of all manage different parameters, and those parameters must be measured in a not invasive way. Then another challenge for new technologies is the solution must be very small, because we don't want something that is too much bulky and that weight, and so that give us not a good, let's say, feeling with that. So small size, reliable, and low cost. But at the same time, we have also to manage another key parameter, that is the accuracy. We said we want to have more data. Of course, the quality of data must be high, so accuracy and precision must be there. And then most of the solutions are portable, so it means that the battery life is key. I don't want to recharge what I have in my body, outside my body, to charge it every hour or every day. It must last as much as possible. And finally, we are talking about ourselves. We want to know more about ourselves, but we want to have a granted data security. So the challenges are a lot and not difficult to manage altogether. But anyhow, we are thinking of that, and we are working on that direction for the MEMS sensors. And let's just start from the sports. What we have done is an analysis on an aspect that in sports today are not very common. Usually, okay, we know what kind of sport we are doing, but most of the time we don't know which is the intense impact or which is the force, the acceleration for the movement that we are doing. And for this reason, we analyze different sports. Here we just report the volleyball, the paddle, boxing, and explosive jumps, but there are many more. And as you can see, there is an intense impact every time that we do a specific movement in those sports. And so, how can it be measured? Today, it's not measured. So what we have done, we worked for a new inertial measurement unit. So it's a MEMS sensor with accelerometers, I want to say plurals, accelerometers, and IMU. And the first target of this new product is to measure at the same time the standard low G acceleration, that is what any accelerometer is capable to do, with the peak, so the high G accelerometer or acceleration. I know today in the market there are solutions, but they are separated, discrete. In here, the magic is that it's all together. And I explain you more later. On top of the combination of low G and high G accelerometer and the gyroscope, the product has also some edge AI on board. There is a technology, an ST technology, the machine learning core, that is capable to classify some events. So combining the sensors, the data from those sensors, it's capable to tell you what is happening. Moreover, inside the sensor, there is also a sensor fusion low power. As we said at the beginning, it's important in one of the challenges, more data we can have together, better is the information you can have from the sensor. And this sensor fusion low power has this capability to combine different signals together. And finally, everything is done in a standard package. So just one chip, it's 2.5 by 3, a standard dimension, all together. What's inside the product? So there is a new architecture, in particular the mechanical architecture, that is combining a gyroscope and two accelerometers that are well synchronized one to the other, and let's say in a very intelligent way, it can manage the high G when it's needed, when there is the impact, and the low G when you're doing your daily activities, combined with the intelligence, the machine learning core, and the final state machine. What can you find in the market? You can find discrete solutions. So you have to make a choice. I want a standard IMU with a low G accelerometer, or I want an high G accelerometer. Or if I want both of them in terms of information, I have to use two different sensors, and they are not synchronized one to the other. Where you can use this IMU, you can find it for sure in the wearable devices. It fits very well in smartwatch, in a smart ring, sport tracker, wearables in general. And it's a big advantage because, as I said before, instead of having two sensors, you just use one. You can process something inside the sensor, and signals are synchronized. But at the beginning, we said we have sports and we have healthcare. So how, as a STMM sensor, we are approaching the healthcare, the well-being that all of us we want? We launched at November a new product family that are the biosensors. And this new product is a combination of two cutting-edge technology. From one side, we have technically called the vertical analog front end, that is an input, an analog input, capable to measure the vital signs, combined with the motion. So we are expert on motion, so we have an accelerometer that is combined that can measure movement. And this is the outcome of a biosensor, this combination of vital signs and movement. But why a biosensor? This is something that we question to ourselves, but also we want to share to all of you. So the big advantage of a biosensor is that from one side, from the technical side, let's say, you have enhanced efficiency. So you have this vertical analog front end very well shaped for vital signs detection. You have power saving because we are talking about microamp of energy. And you have, again, the bill of material reduction because instead of having two sensors, you have just one. But it's not enough for the advantage from the technical standpoint. We want to have advantage for us. And with biosensor, we can do the predictive maintenance of our body. So let's change the focus. Usually we do predictive maintenance for machine, but we have our body, and we should have some predictive maintenance. And so through the biosensor, you can have meaningful data because you can combine the vital signs with the motion. And the result is an enhanced information. You have biosignals that are continuously monitored along all the day, whatever is the situation where you are. And through the biosensors, you can trigger also some other events. But let's go deeper in the applications. So what kind of measurements we can do with a biosensor? The first one, and the most intuitive, it's the electrocardiogram. So you can measure your heartbeat rate. But we can go further on that. There are other vital signs that are really interesting to analyze in our daily. The first one is the electroneurography. So it's the capability to measure our nerve system, and thanks to that, we can understand which is our intention. So before doing a movement, before doing a motion, first of all, we have an intention. And through the biosensor, you can measure it. Another type of measurement that you can do, it's the electroencephalography. So you can put the sensor around your head, and you can measure what is happening at your brain. I don't know if it's good or not, but anyhow, it can be possible. And finally, the seismocardiography, so the measurement of your heart through the acceleration, not only through the vital signs, but also the acceleration. And there are many applications where the biosensor makes sense because it's something that we wear, that it's always with us as technology. Just a few examples of what we have done with the biosensor. This is an activity in conjunction ST with DuPont. DuPont is an important customer in the medical field, and they are very specialized on smart patches. We combine their smart patches with our biosensor, and we build up a design platform that can perfectly have not only the electrocardiography, but a context-aware electrocardiography. It means that we can combine the measurement of the heart rate with the motion, and so we can remove any artifacts and have a clean signals of our heartbeat. Another example is this ENG, as I said before, this neural system monitoring. And in here we collaborate with a partner, Python, and a final customer, Timex. In this case, it's a smartwatch. And the capability of this smartwatch is to measure our mental health. I don't know if we are happy, but anyhow, it's good to know how is the status of our mental health, how is done. So, through the vital sign of this ENG, the neural signals are captured, are then elaborated through AI algorithm, and the contact are some electrodes in the smartwatch, and the outcome is really your status for your mental health. Back again to sports, because let's remember that we have the convergence, and this is an example only on sports in tennis, and if you can see through this IMU, we measure not only the impact intensity, but also what kind of gesture you have done. There are 3 different, let's say, positions for tennis, and through the sensor you can measure the peak, the intensity, but also what kind of movement you are doing. So as a conclusion, let's really train like a pro. We have the possibility. We are working from the technology standpoint to make it happen for everybody because, again, we want to live longer and better. And so combining these 2 technologies, the IMU with intensity impact and the biosensor, we can really have some wearable solutions that can be appreciated by all of us. At the end, what we are offering, it's anyhow from the technical standpoint a big advantage because we are compacting more sensors together, synchronizing the data, and as outcome are a better quality of data analysis, and so information for us. So, if you are curious, you could come to our booth. There are both a demo for the intensity impact and also the demo for the biosensors. You can also have a look to the smartwatch about the ENG, and I'm waiting for you there. Thank you very much for your time. Any question? Curiosity? So thank you.